from that equation there, we can continue with the dA is the same for all of the components, so we can divide by dA from that equation. So let's divide by differential areas dA. So what we will have, put the negative on the other side, so we will have a very clean, good equation, and we almost get there for the first equation. Sigma x apostrophe is equal to sigma x cosine square theta, and then you have sigma y from that equation, sine square theta plus 2 tau xy sine theta cosine theta. So with that, we can use our trigonometry substitution. We can have even a nicer equation. So let's use in geometry substitution. Use geometry substitution. If you don't want to, you want to more detail, you can go to the page 41 to 42 of your textbook. 41, 42 of textbook to be more detailed of how to do the substitution here. So from that equation, we can have sigma x apostrophe equal to sigma x. From that equation above, we have sigma y divided by 2 plus sigma x minus sigma y divided by 2 cosine 2 theta, and then plus tau xy sine 2 theta. So that what you have, and box for find out the normal stress in the x apostrophe plane from an angle theta from the original plane, original coordinate xy. And of course, similarly, we submit from on the force in x apostrophe direction, we can be able to do the same for sum up all the force in y apostrophe direction. And you don't want me to go over details similar again, we just know that now if I sum up on the force in y apostrophe and assume positive, you go to the y apostrophe, positive y apostrophe as well. So from that, it will yield, and again, if you want, also go to the book page, starting from page 441, it yield what? It yield the equation for tau x apostrophe and y apostrophe. So here, no, tau x apostrophe y apostrophe equal to negative sigma x minus sigma y over 2 sine 2 theta plus tau xy cosine 2 theta. And let's box that equation to be able to find out the tau x apostrophe y apostrophe. So from that, with that two equation, as you can see here, go back to this plot. If I know sigma x, sigma y, and tau xy, which is given, we can be able to find out sigma x apostrophe and tau x apostrophe y apostrophe with the angle theta and the normal stress, shear stress of the x and y as you have it in this equation. So very important to understand this one. And let's with that, I'd like to stop here to do the worksheet 12C, and then we come back to the principal stresses, and there are many other concepts we deal with in today. So it's very abstract, easy to confuse, so watch carefully when you go with that lesson.